Hello students, today we are going to learn about spectrum for class 10 physics, right? Now in the earlier classes you all must have learned about prism as to how deviation is produced in a prism. Now in this part I am going to explain about deviation, dispersion and spectrum, followed by electromagnetic spectrum, and towards the end I am going to explain about scattering of light. Right? Now what is a prism? Basically a prism is a transparent reflecting medium which is you can imagine as if it is being cut out from a glass slab. Okay, so since you all have already learned about a prism, I am going to show you all how deviation is produced in a prism. Okay, so so this is a triangular prism which is being used. Okay, when light is incident on one surface of a prism, there will be dispersion of light as well as deviation of this incident ray. Now this incident ray, when it is incident on this edge of the prism, you find about the normal, this ray, instead of going straight, if the prism is removed, you find this ray will go straight without any deviation. Because of the presence of this prism, you find instead of this light, I am going to show it using dotted lines, it should have gone straight if the medium was same throughout, but instead there is deviation. So this prism deviates from its path, it takes this path, there is refraction occurring at the air glass interface, and at the second interface about the normal, if I draw a normal, you find this ray will bend further, okay, and it will deviate towards the base. So this is your incident ray, this is your refracted ray, and this is your emergent ray. Right? Now the actual deviation delta which is produced is this angle which is formed between the incident ray when it is being produced and the emergent ray when it is being produced backwards. So this delta is the sum of this deviation, first deviation which is produced, if I write it as delta 1, and the second deviation that is produced, which is, if I just produce this, and delta 2. So this deviation is produced due to, it is the sum of delta 1 and delta 2. So I can write it as delta 1 plus delta 2 is the total deviation produced. Now what is this deviation? What are the factors affecting deviation produced in a prism? Now factors are, the first factor is it depends on the angle of incidence. I is the angle of incidence. So angle of incidence. Next, it also depends on the angle of the prism. Angle of the prism. And the third factor is it depends on the refractive index of the prism. Alright, so now we are not interested in this lesson, we are not looking at this part, that is how deviation is affected by the angle of incidence, but we are going to concentrate on this, that is the refractive index. Now refractive index will change due to the wavelength, change in wavelength. If the wavelength of light that is being used is different, again the refractive index will change, right? So if we are using a monochromatic light, that is a light having just one color, you are going to have one ray and one single ray will get refracted, and the emergent ray also will be one single ray. But instead, if you are using a polychromatic light, or if you are using white light, that is sunlight, so in that case you find after this incident ray, when white light is incident on this type of a prism, you find at this interface there will be deviation and there will be dispersion. Now dispersion is nothing but the splitting of white light, okay. So at the first interface there will be deviation and there will be dispersion. So when white light, when the incident light is white light, you find it will get dispersed into its constituent colors, and when they emerge out, that time you find there won't be any dispersion, but there will be further deviation. So total deviation is delta 1 plus delta 2. Now color is something which is related to the wavelength. So a particular color will have a particular wavelength. Now white light, as we all know that white light consists of 7 different colors, okay. Now when light is incident, white light is when this prism is placed in front of a sharp beam coming from sun's rays, you find after deviation there will be dispersion, and you are going to get a sharp image when you place a screen, and you are going to get 7 different colors, a band of 7 different colors. Which are those 7 different colors? Okay, I'm going to, okay, the incident ray about the normal, you find there will be dispersion in such a way that you are going to get and this same band, when it comes across this surface, you find there will be deviation produced, and you are going to get colors like this. And the order in which these colors are placed will be: violet will be right at the bottom, followed by indigo, blue, green, yellow, orange and red. This is the order. Now if you observe, red color has got the highest, or you can say the longest wavelength, so it is placed right on top, whereas violet, which has got the shortest wavelength, will be placed right at the bottom. In the prism, when white light is incident, there will be deviation and dispersion occurring, and the order in which the colors will be seen will be: red will be right on top, orange below that, yellow, green, blue, indigo and violet. If you look at this violet band of color, this last band, you find that it is deviated the most, and violet is the one which has got the shortest wavelength, whereas red has got the highest or the longest wavelength, okay. Now you can say that wavelength of red is greater than the wavelength of the other colors, and then eventually it is violet, right. But deviation produced will be most in case of, now delta for red will be less as compared to deviation produced for violet, right. Now if you look at this, okay, you can see a prism and white light is incident on it, and then you can see a band of colors which is produced. Now what is dispersion? Dispersion is nothing but the splitting of white light when it passes through a prism. You can see it is got split into 7 different colors, and this band of 7 colors is known as spectrum. Okay. Now what is an electromagnetic spectrum? Now if you look at the red end, it will have the highest wavelength, and if you look at the violet end, it will have longest wavelength. Now suppose you bring a blackened bulb thermometer close to, or you can move it from the violet end to the red end, you find there will be a slight steady increase in the temperature. But when you place it close to the red end, you find there will be a sudden increase in temperature recorded on the thermometer. Now why is that so? It is because there must be some invisible rays which are present here, which are being detected by the blackened bulb of the thermometer. So those rays are called as infrared radiations, which are not sensitive to our eyes, so we are not able to feel those radiations. If you bring a silver sulfide screen close to this end, that is a violet end, you find there will be fluorescence produced on this on the screen of silver sulfide on the silver sulfide screen. So that means again there is something present beyond the violet end. So what is that? Those are nothing but ultraviolet radiations. So in the same way, when I say electromagnetic spectrum, it is a broader view in which there are many other radiations also present. So visible part is just a small section of this entire electromagnetic spectrum. Okay. So the next part is electromagnetic spectrum. Now in this electromagnetic spectrum you have visible section, so you can just show it as a band here. When you have visible section somewhere here, it's the visible section. You have the ultraviolet radiations, you have X-rays, you have the gamma radiations. Then you have violet here and red over here, and beyond red you have the infrared section. Infrared radiations followed by microwaves and radio waves. If you look at the frequency, you find it frequency which is denoted by mu. Okay, frequency here will be higher and frequency over here will be lower. So frequency increases as you go from radio waves to gamma radiations, whereas wavelength increases as you go from gamma radiations to radio waves. So you will find that radio waves will have maximum wavelength as compared to gamma radiation. So as you all know that wavelength and frequency are inversely related. Higher the frequency, lower will be the wavelength, lower the frequency, higher will be the wavelength, right? And the visible section is here. You have infrared. So radio waves are the waves which have the longest wavelength, and then you have microwaves, infrared, visible, UV radiations, X-rays and gamma radiation. Now gamma radiations will have the highest frequency, but they will have lowest least wavelength. Now what are the properties which are common to all these radiations? Okay, they all travel with the at the speed of light, which is equal to 3 into 10 to the power of 8 meters per second. Then find these radiation, they can travel through vacuum. Then you have only the visible section here. They are not deflected by you can say electric or magnetic field. Okay, then they obey the laws of reflection and refraction. So these are some of the properties which are common to all these radiations. Okay, and then towards the end we are going to learn about spectrum. Now spectrum, as I have already said, is a band of 7 colors which is obtained. Now Newton, when he was trying to use certain lenses to focus sunlight, it was observed that he would see towards the edges of the lens, either edges, he would see certain colors. So initially he thought that those colors are due to some dust particles or some aberrations which are present within the lens. He tried to use a polished lens, but then again he could see the those colors towards the edges. So what he tried to do was he tried to use a prism, and under control conditions, when a fine beam of light was allowed to enter through the window and it was incident on the prism. So when that light, white light, sun's light, was incident on the prism, on the other side when a screen was being placed, a band of 7 colors was obtained, and that is nothing but a spectrum which consists of 7 colors. Okay, and those 7 colors, if you use another prism in such a way that you invert it and place it, you can again get white light from those band of 7 colors. Now what you need to remember is that dispersion occurs only at the first surface and deviation occurs at both the surfaces, right? Next is scattering of light. What is scattering of light? Now many a times it so happens that suppose there is a small opening present, and when sunlight is allowed to enter through the opening, and you find, suppose there are dust particles in the room, then you find through the small opening, when light enters the room, it gets light spreads in a certain direction. Okay, so if this is a small room, small aperture which is present, and then light enters, so due to the presence of these dust particles, those dust particles, they get illuminated and light will get scattered. So what is scattering? Scattering is nothing but the absorption of light by these dust particles and re-emission of that light. Okay, now the dust particles, they have smaller wavelength as compared to wavelength of light that is entering. So they absorb the light, and without absorbing the light energy, they emit those radiations. Light radiations are being emitted. Now this phenomena was being observed by Tyndall, and it is also known as Tyndall effect when you are using colloidal solution. And when you use a beam of light, you can see in colloidal solution you find that path gets illuminated. So that effect is called as, it was being studied by Tyndall, and it is called as Tyndall's effect, when the path is illuminated due to the presence of colloidal solution. Same thing is being observed in case in forest, when sunlight enters through the canopy, you find a scattering of light. You can see light entering through from small spaces, and it spreads. Again, that is due to the presence of dust particles, then fog which is present. They will absorb the light and then re-emit it. So you can see that portion gets illuminated. Now, where in real life, in fact, there are many applications of scattering of light. Now, red color of the sun during sunrise and during sunset is due to scattering of light. Now, blue color of the sky again is due to scattering of light. Then you can see clouds which are white in color, again it is due to scattering of light. Danger signs are red in color, signals are the danger signals, they are red in color, again it is due to scattering of light. So I'll just give you one example related to reddening of the sun. Sun appears to be red in color during sunrise and during sunset. Now why is it so? The reason is because of scattering of light. So now you will have learned that sunlight consists of 7 different colors. Okay, so suppose this is the earth, the horizon, and this is the sun. So as the sun is rising, you find it has to cover long distance. Okay, the distance is quite long. So what happens is, suppose the observer is observing the sun from here. What happens is that due to this distance involved, now as you all have already learned that red color is having the longest wavelength and violet color is having the shortest wavelength. So red color, since it has got longer wavelength, it will travel faster. The speed of red color is much faster as compared to speed of violet color, okay, since it is of the longer wavelength. So red color reaches the observer who is present far away from the sun, whereas the other colors which are present in the spectrum, they get scattered. So most of the colors get scattered, and red color is scattered the least. So it is being seen by the observer during sunrise, and same thing happens when the sun sets. So it is because of the distance involved, other colors get scattered. Then another example would be sky appears to be blue in all the other direction except the direction where sun is present. Now again you can explain this using scattering. Since blue color has got the least wavelength, it scatters the most. So if you look at the sun in any other direction other than looking at it directly, you find that light which we can see is the blue light due to scattering phenomena. And another thing is wavelength of blue is least as compared to wavelength of other colors. And of course you have violet, indigo colors also, but in reality the sky appears to be violet, indigo, but what our eyes can perceive is blue color more than the than violet and indigo color. So that is the reason we see it. Before blue also you have indigo and violet present, but we don't see the light as violet or indigo. Instead it is blue in color, because our eyes are sensitive to this blue color. Okay, thank you students.